much to do. I have a question for you. Let's start out with this. What month of the year is the Earth closest to the Sun? I need a month. I have an August. I have one vote August. July. I have 2 votes July. We got 1 vote winter. Don't know what month. What month is Earth? We got 1 vote June.
September.
Okay. People are mixing it up now, just throwing out random months. All right, let me tell you a quick little story on this. One day, a couple of years ago, my parents call up out of the blue in the afternoon. I'm like, what are they calling about? And my mom's like, quick, what month is the Earth close to the Sun? Now, they're sitting, they're in Illinois, and they don't have a whole lot of interest in astronomy. So I'm like, wait, what? And she goes, it's the final Jeopardy question. I'm like, really? Like, you couldn't wait a couple minutes to hear this from Alex Trebek. So I kind of chuckle, and I'm like, well, the answer is January. I know some of you were saying that. And my mom's like, no, closest to the Sun. And I'm like, January. and I hang up. I wait a couple minutes. She calls back. Well, why is that? Guys, what causes our seasons? I don't think I heard the right word. So wait, would you say axis? What about the axis? What about it? The tilt, the angle, the tilt of our axis. That's what causes... Good job, Jamie. That's what causes our seasons, guys. The tilt of our axis, not how far we are. Not how far we are from the Sun. So, because the Earth travels in just about a circle. It's an elliptical orbit, but it's very, very circular orbit. We're almost the same distance all year round. That's what I want you to remember. We're almost the same distance all year round. But because it's elliptical, look at this. Technically speaking, the closest we get to the Sun is actually on January 4th every year. January 4th, isn't that interesting? Now here's a new vocabulary term for you. The closest point of an orbit is the perihelion. P-E-R-I. Add that to your notes. Perihelion, the closest point of an orbit. P-E-R-I-H-E-L-I-O-N. Our closest point to the Sun. Closest point to the Sun there, perihelion. And the farthest point happens to be on the 4th of July. And that's called aphelion. A-P-H-E-L-I-O-N. Perihelion, aphelion. Now, the difference is very small. Look at the difference literally in the size of the Sun. It's slightly bigger on January 4th and July 4th, and those are the two extremes. It makes very, very, very little difference, and apparently it's not enough to affect the weather in any way. So this does not affect our weather, because it's such a slight difference. But technically that is true. We are closest on January 4th and farthest. I always remember aphelion as away. The A is for away. Aphelion's away. That's the farthest point in the orbit. Let's talk about the tilt. How much are we tilted?
23.5 degrees.
23.5 degrees. That is a key number to know. You should remember that for middle school, grade school. 23.5 degrees. Now you'll notice that we stay always tilted at 23.5. We always are tilted at 23.5. Look at this. Tilted 23, tilted 23.5. Now look, in the month of June, the Sun's rays are as far north as possible. That is called the summer solstice. The longest day of the year, usually right around June 21st or so. And the Sun's rays are going as far north as possible. They come up to the Tropic of Cancer at 23.5 degrees. Now in winter, in our winter, we're still tilted the same, but now the Sun's rays are as far south as possible. They go 23.5 degrees below the equator. Of course, that makes it summertime. in South America and Australia and so forth, and our winter time. That's called the winter solstice, and right around December 21st or so, you're going to have, the shortest day of the year. Those are the solstices, the extremes. In between, when it's, let's say, fall, for example, the sun's rays are hitting where? Right at the what? At the equator. So you can remember equinox, equator, and you can also think equinox, equal day and night, when day and night are equal. Equal day and night. And of course it happens in the spring in March, right around March, 21st or so. The spring equinox. I know you've all had that before. Are there any questions on the equinoxes and the solstices? Here's a question for you. Where does the sun rise? East? Okay, all right, fine. Where does the sun set? West. Where is the sun at noon? At your zenith. Oh, good term. Good term. Right above your head? In South Florida, what if I told you there is not a single day of the year where any of that is true? Technically speaking. Technically speaking, there's not a single day of the year when the sun is rising due east, going right above your head at noon, and setting due west. Here's what I mean. Let's say it's the summer solstice on June 21st. Here's what's happening. I said the farthest the sun gets is to 23.5 degrees. What is our latitude in South Florida? 26. So technically, the sun is rising a couple degrees south of east. You see what I mean? I know, I told you technically speaking. And it's not technically right above your head. It's a couple degrees south. And it sets a couple degrees south of west. Yeah. You're not going to notice any difference, are you? It's just going to look east and right above your head. Now, but remember, guys, that's in June. Now, here's what we're going to do this year. By the time we get to December, it is going to be noticeably different. I'm going to have first hour, and maybe you guys somewhat as well, but first hour is going to go out. Maybe they're going to take pictures of where the sun is rising every day. Fourth hour, near lunchtime, they're going to actually measure with the meter sticks the height of the sun in the sky. And when we get to December, guys, it is going to be noticeably different. The sun will be rising way to the southeast, setting way in the southwest, and it is going to be nowhere close to being over your head at noon. And we'll measure it in the sky, and you'll see what I mean. We'll measure it with the protractor and get the exact angle. It changes a lot. And guys, that's from South Florida. This effect gets much worse the farther north you go. I'll show you a picture in just a second illustrating that. So let's take a look at some of the things that are affected. This is all due to the fact that we're tilted. How high the sun is in the sky, how high it gets at noon. That's different every day because of our tilt. The length of the day. I grew up in Illinois. I remember how depressing it was. I was a kid. I loved to be outside. And I was always depressed in the wintertime. By the time I walked home from school in the winter, it was already getting dark. You know what I mean? We had about an hour to go throw snowballs at kids, and that was it. And then all of a sudden you're being called inside. I hated that. Of course, the summer was fantastic. We were out till late at night. You hear the moms calling everybody in. Where the sun rises and sets, that's one you don't think about. When I think about it, when I'm driving here and I go by the canal, right by Sawgrass Expressway, I kind of look at where the sun is positioned. I notice how different it is by the time we get to December than it is now. All of these things are going to change throughout the year, and I want you to start noticing them. Here's what it looks like in wintertime. I don't know where this picture was taken, but the sun is going to come up way in the southeast. It's not going to get high off the ground. I'll tell you when I notice it, if I go home, let's say for Thanksgiving, I go back to Illinois for Thanksgiving, we always play a family football game. And now I'll be out there around noon, and I'll kind of look, and I'll be noticing the fact, wow, the sun is so low in the sky. It's noon, and the sun is way low. And that's why it's wintertime. We're not getting its direct rays there. And it gets worse and worse and worse the farther north that you go. Pay attention to that. If you're traveling somewhere north, pay attention to where the sun's at, and you'll notice that it's getting very different as you get into wintertime. Here's a quick reminder. Go ahead.
Illinois in the summertime, should be really high.
Yeah, well, I mean, it's much higher than it is in the winter, but it's still never going to be right above your head. Yep. Here's just a refresher here of the seasons. Let me go back to this very quickly. I want to mention something. If you extend this, I'm talking about growing up in Illinois, but what if you go farther north? It gets to a point, guys, as you get farther north, there's a point where there will be a day on the winter solstice when the sun actually doesn't rise. One day a year where the sun doesn't break the horizon. Yep, it's not really dark. You'll have like kind of a dusk time, but it's going to be dark most of the day, most of the night. Do you know where you are? Not quite yet. You could be in Alaska. You're at the Arctic Circle. At the Arctic Circle, there's one day a year where the sun never rises, but guess what? 6 months later, there's one day where the sun never sets. The sun never goes down. Isn't it interesting? That's at the Arctic Circle. But guess what? If you go farther north from there, it gets even worse. If you go farther north, there's going to be a place where there's a whole week where the sun never rises in the winter, and a whole week in summer where it never sets. And then what happens if you lived right at the North Pole? What do you think? Excellent. That's exactly right. 6 months of daylight, 6 months of darkness. There's a zombie movie called 30 Days of Night. No? Anyway, in this movie, let me think what it is. The town's being attacked by vampires, and so they have 30 days in which the sun's not going to rise, and the vampires are just free to go crazy and kill everybody. So you have to kind of survive that 30 days till the sun comes back up. But it's true that there would be a place, there are towns where that's exactly true, where you would have 30 days of darkness in the winter. Any questions?